Hello App Inventors, this is a walkthrough of Helicopter Rescue FS. The FS stands for Fixed Size Canvas. A previous version was tried using image sprite swapping for scrolling horizontally and vertically, which would in theory give the ability to have a virtual unlimited canvas size, but that idea has been put on hold for now. If you can figure out a way to do it, please share your solution with other members of the App Inventor community. Thanks. This game is based on the epic 3D helicopter rescue game by Magnapop and Snoopy for Hopscotch. I've simplified it somewhat for this project. The idea of the game is to rescue survivors of a boating accident that are in the water by touching areas of the canvas to guide a rescue helicopter to pick them up. You're given a hint by the red arrow that points in the direction of a survivor to know where to touch. I'll play it a minute or two for you to get an idea how it works. Control F11 to rotate the emulator. When I click or tap the screen, the helicopter will turn to follow that. Here we have a survivor in the water. Movement's rather jerky on the emulator, but it works okay. Now when the helicopter is positioned over the swimmer, it picks up the survivor and will spawn that survivor somewhere else off of the screen, and the arrow will point at the location where that swimmer is. Notice when I clicked on the screen, the helicopter turned in the direction where I was clicking. Works much better on a tablet or a phone. It's a little quicker. But this gives you the idea. Alright, so we've rescued 3 survivors. Okay. So that's the idea. So let's look at the screen designer first. The layout and media assets here, and the screen align horizontal and align vertical are set to center for the screen. Screen orientation is set to landscape. It keeps saying simple, and I find a wider screen easier to work with than a tall, narrow screen for gameplay. Screen sizing is set to responsive. That gives a crisper graphics display and a larger play area on tablets. The game canvas is nested inside a set of horizontal and vertical arrangements. By adjusting their widths and heights, this allows the game canvas to be moved in any direction and amount, giving the appearance that the ocean is moving under the device screen. This layout was determined by experimentation, and there may be a simpler layout, but I know this one works. If you can make one simpler, please post an example for others to benefit from. Thank you. The vertical arrangement, that is a container for the other arrangements in the game canvas, is called the boundary. It's set to fill parent in width and height here, but it's set to a larger size in the blocks viewer. Within or inside boundary is another vertical arrangement, Y-spacer, that will expand and contract in height during gameplay to push and pull the arrangements below it. That includes the game canvas, and it moves the game canvas up and down. Below Y spacer and also inside boundary is a horizontal arrangement named underscore. It's a container for another horizontal arrangement and the game canvas. Inside underscore horizontal arrangement is the X spacer horizontal arrangement and game canvas. X spacer pushes and pulls game canvas left and right. Inside game canvas is the swimmer image sprite that represents the survivors and is respawned at random positions on the canvas. The helicopter image sprite moves across game canvas and turns in the direction touched by the player to pick up survivors. An arrow image sprite moves along with the helicopter, and it rotates to point in the direction of a swimmer, giving the player a hint where to touch on the canvas in order to guide the helicopter to the swimmer. So its rotates property is ticked or enabled. The update helicopter clock moves the canvas. And points the arrow at the swimmer and displays the animation frames for the helicopter. There are 11 sets of 3 pictures in the media folder to give helicopter the appearance of pointing in one of the 11 directions and for rotating the rotors. You see those here. The radio comm notifier gets input from and it displays messages to the player. The engine player component plays the helicopter engine sound effect. The update scoreboard clock keeps the display of the number of survivors centered at the top of the screen as the canvas moves and changes position. The update swimmer clock tests if the swimmer is under the helicopter, and if so, respawns the swimmer at a new location and does a treading water animation. Now let's switch to the blocks viewer. The About Procedures comment bubble contains a link to a video of the original hopscotch game that inspired this App Inventor project. Let's look at the global variables. Rotor frames is a list of 11 items where each of those items contains a list of 3 pictures that are used to animate the helicopter's rotor blades and face the helicopter in a specific direction. Swimmer frames is a list of picture file names used to make the swimmer image sprite appear to be treading water. Target size is used to set the size of the area under the helicopter where a swimmer is considered rescued if the area is over the swimmer. Frames index is an integer between 1 and 11 that determines which set of 3 pictures is used to animate the helicopter. X-spacer max width is set to the maximum width of X-spacer width, X-spacer width is used to move the game canvas left and right. Y-spacer max height is set to the maximum height of Y-spacer height. Rescued is the counter value for the number of swimmers rescued by the helicopter. When screen 1 initialized does these things. It uses responsive sizing to set the various visible component sizes to percentage of the screen dimensions. This allows the game to adjust to any device screen size and still look great, even on the AI2 emulator. Here we display also the welcome dialog box, and when the player taps a button in the dialog box, the radio comm after choosing event block is executed. So let's look at that. If the user has tapped either the play button or the quit button in the radio comm show choose dialog pop-up and they chose play, the actors in game canvas are enabled and set visible. The paint color and font size for the scoreboard are set. The helicopter speed is set. The X-spacer max width, let me move this here. The X-spacer max width and height are based on the current device's screen dimensions. We start playing the helicopter engine sound, and we start the helicopter and swimmer animations. If they chose quit rather than play, then the application would close. Okay, I think we're finished with this, so let's go on to update helicopter timer. Let's look at the when update helicopter timer event block. This event block updates the game canvas position based on the location of the helicopter. It keeps the arrow positioned above the helicopter and pointing at a swimmer. It displays the helicopter picture frames. The helicopter is constantly moving, and we want the game canvas to move in the opposite direction to keep the helicopter on the screen. When the helicopter is against the left edge of the game canvas, helicopter X is 0, and X-spacer width is equal to X-spacer max width. When the helicopter is against the right edge of the game canvas, the helicopter X is game canvas width minus helicopter width, and X-spacer width is 0. So the helicopter X value and the X-spacer width value are inversely proportional. When one goes up, the other goes down. We'll use the linear interpolation formula to determine the X-spacer width for any helicopter X value on the game canvas. Y equals Y1 plus X minus X1 times Y2 minus Y1 divided by X2 minus X1. Substituting, Y is X-spacer width, that's to be calculated. X is the current helicopter X value. Y1 is X-spacer max width, that's the maximum value for X-spacer. Y2 is equal to 0. That's the minimum value for X-spacer. Y1 is equal to 0. That's the minimum value for helicopter X. X2 is equal to the game canvas width minus the helicopter width. That's the maximum value for helicopter X. Since you'll recall, an image sprite cannot move off of the canvas. X-spacer width equals X-spacer max width plus helicopter X minus 0 times 0 minus X-spacer max width divided by game canvas width minus helicopter width minus 0. Simplifying, X-spacer max width minus helicopter X times X-spacer max width, I just moved the minus sign in the front, divided by game canvas width minus helicopter width. And that's the formula that you see used here. Y spacer height is determined in the exact same way. The arrow should always hover above the helicopter. And this is what positions it relative to the screen width. Since the arrow rotates property is set to true in the designer, then this block executes. When this block executes, the arrow will point to the swimmer and arrow heading will be set to that angle. Display the next of 3 helicopter pictures for the current frame index. That's what next frame does. Next frame is a general procedure with result to display a list of images one at a time. It's used to animate the helicopter and swimmer. The update scoreboard timer, as said before, refreshes and keeps centered the number of survivors. It maintains the top center position as the canvas moves across the screen. Let's look at the update swimmer timer. Okay, this part determines if, and we'll move this down, determines if the swimmer is under the helicopter and can be picked up. This takes the place of the helicopter collided with event block. It allows fine-tuning of the area beneath the helicopter, where a swimmer image sprite will be detected by comparing the distances between the center points of the helicopter and swimmer image sprites. If that distance is less than the global target size value, then a collision has occurred. If a collision has occurred and the swimmer can be picked up, then the show alert notice says we've picked up a survivor, continuing search. And global rescued is updated. One's added to global rescued because we're picking up a swimmer. So the next thing we need to do is spawn that swimmer in a new location. So let's make room for that comment block. It's a big one. A swimmer has been picked up. Yay! Now the app needs to spawn a new swimmer for the helicopter to rescue. Determine the minimum and maximum XY values for a new swimmer to spawn off screen out of view. Then spawn the swimmer. Why make a new swimmer spawn out of view? It looks more realistic than if the swimmer spawns next to the helicopter or worse, under it, resulting in an immediate pickup in score. An additional restriction is that I always want the helicopter to be able to pass between the swimmer and the edge of the game canvas. Why do this? Because if the swimmer spawns too close to the edge of the game canvas, the helicopter's target size area may not be able to pass over the swimmer, resulting in a swimmer that cannot be saved. So when you see swimmer width plus helicopter width or swimmer height plus helicopter height in the formulas below, that situation is what's being tested and prevented from happening. To make it easier to figure out what these values should be, I made models of the parts of visible components using business cardstock. The boundary, which is 4 times the screen width and 4 times the screen height, was made with 4 business cards wide and high, with a hole in the center the size of a business card to represent the device screen. The game canvas was made with, which is 2.5 times the screen width and 2.5 times the screen height, was made with 2.5 business cards wide and high. Helicopter rectangle cutout was about 1/8 the size of the game canvas. The swimmer rectangle cutout was a little smaller than the helicopter. I set the game canvas cutout over the boundary cutout and determined the minimum and maximum values for swimmer X and swimmer Y, such that swimmer is spawned outside of the screen area and always has room for the helicopter to move outside of it and still be within the edge of the game canvas. So there would be room for the helicopter to pass to the swimmer's left edge on the left side of the game canvas and all other sides as well. 2 sets of minimum X and Y values are used. One set for points to the left of and above the screen area, that's min LFX, max LFX, min LFY, max LFY, and one set for points below and to the right of the screen area, min RTX, max RTX, min RTY, max RTY. Creating a random integer that is in between these values will ensure that the swimmer will spawn outside of the visible screen area, but only if there is enough room for the helicopter to pass next to the swimmer. In the first if block below, the test for max LF is X spacer max width minus X spacer width is greater than or equal to swimmer width plus helicopter width. If this test result is true, then there is enough room for the swimmer and a random value within the min LFX max LFX range can be included in the X list. The X list is used to pick the swimmer X value from either one of 2 values. If there is room for the helicopter to pass on the left and right of the swimmer, then 2 X values will be added to the X list. A random integer between min LFX and max LFX, and a random integer between min RTX and max RTX. If there is no room for the helicopter to pass on the left of the swimmer, then only the random integer between min right X and max right X will be added to X list. If there is no room for the helicopter to pass on the right of the swimmer, then only the random integer between min LFX and max LFX will be added to the X list. The swimmer's new X value will be randomly picked from the X list. The Y list works exactly the same way. Note that there will always be at least one value in the X list and Y list. Okay, so you can read that while you're looking at these blocks. Here I've just specified what the minimum and maximum values are based from what I got from looking at the cardstock. And I mentioned this first test here. Test if the helicopter and swimmer can fit side by side between the left edge of the game canvas and the left edge of the device screen at the current X spacer width. And here we want to test if the helicopter and swimmer can fit side by side between the right edge of the game canvas and the right edge of the device screen at the current X spacer width. Here we test if the helicopter and swimmer can fit stacked one above the other between the top edge of game canvas and the top edge of the device screen at the current Y spacer height. Finally, here we test if the helicopter and swimmer can fit stacked one above the other between the bottom edge of the game canvas and the bottom edge of the device screen at the current Y spacer height. So once all of these tests are done, we either have one or two values in X list and Y list. We pick a random item from those lists, and then we move the swimmer to that location. And then this just animates the swimmer. It cycles through each of the 9 pictures one at a time each time this timer block executes to give the swimmer the appearance of treading water. Okay, let's move on. When game canvas touchdown is triggered when the player touches the screen. It sets the helicopter heading to point towards the tapped XY position on game canvas. We then call Get Helicopter Frames Index to use the new helicopter heading to set the global frames index variable. Using the current heading, find the frames index that can be used to select the set of 3 pictures of the helicopter that is closest to that angle. The pictures in the global rotor frames list represent rotation angles of the helicopter in increments of 30 degrees, 0, 30, 60, 90, etc. The next frame procedure with result then displays those frames in the When Update Helicopter Timer event block. Well, that concludes the description of the blocks used for this project. I hope you found this to be useful. Until next time, happy inventing!